Hello, welcome everybody. We would wait for another 1 minute and then we are ready to begin. All right. Good afternoon, ladies and gentlemen. Welcome to our third webinar in the series that BM Process is organizing since a couple of months. Some of you might have joined first time and some of you might be third time. I'm Amol, I'm your host for this webinar, and together I have two guests, Bart and Frank. And today's webinar is for the non-thermal solution. Title is Nature-Inspired Emission Control, How UV and Plasma System Transform Industrial Air Treatment. As we know, industrial facilities are under increasing pressure to reduce odor, VOC, and harmful emissions while improving energy efficiency and meeting stricter environmental regulations. Traditional thermal solutions are effective, but not always the most optimal or most sustainable choices for every exhaust stream. In this webinar, BM Process and Oxytec jointly explore how nature-inspired non-thermal technologies such as UV and plasma complement thermal emission control solution and where they deliver the greatest value in industrial air treatment. This is what we are going to learn in this webinar, where non-thermal UV and plasma technology fit, mostly the emission control landscape, how this system treat low to moderate VOC emissions. We're also going to discuss the difference between thermal and non-thermal treatments and their approaches. What are the industrial applications, whether it's chemical, food and feed, wastewater, recycling, and different manufacturing. And we're also going to learn how to validate feasibility before investment starts. Before I begin, a quick practical tip. By default, all of you are on mute. However, you will have an opportunity to chat with us in the chat function. We're also going to have different polls so that speakers interact with you. And if there are any questions, put it there. And towards the end, we're also going to have short question and answer sessions where I would read those questions for you and discuss directly with the speakers. So let me talk about our first speaker. Recently, some of you might have seen Bart has put this nice video on the social media. And some of you who know about Bart, he loved the smell of fresh air, but not only in his farm, also in the industrial plants. And that's what he's helping to different industries since several years. He designed the solution that offers you fresh air. A quick background about Bart. He's an experienced process engineer, consultant, and entrepreneur with more than 20 years of experience in industrial engineering and emission control projects. He's a founder of BM Process Management and support clients with emission control technology, process safety studies, project management, and commissioning support. He has led and advised projects across tank storage, chemical processing, food and feed, and energy intensive industries, and is a recognized expert in a vapor recovery odor abatement. Next, we have our guest from Oxitec. And if you ever wonder what happens inside the UV reaction chamber, Frank has probably designed it, tested it, and improved it. He has more than 30 years of experience, so it was difficult for me to put all the experiences and his background in one slide. So if you read, his work focuses on innovative and resources efficient photo oxidation technologies. He's the that remove VOCs, odors, aerosols, and smoke from industrial exhaust stream. He's also the inventor and developer of patented photo oxidation technology implemented for renowned international customers. Through New Fox, which is new photo oxidation, Frank works as an independent consultant and technology developer, supporting industrial clients in selecting the right technology, designing system, and developing regulatory compliant exhaust air purification solutions. In parallel, Frank served as a global sales director industry at Oxitec, where he's responsible for the design, application, and implementation of industrial UV and plasma system for air purification, including VOC reduction, odor control, and disinfection. Next 8 to 10 minutes, we are going to listen to Bart, and then I would also get Frank on the screen, and he will talk more about whatever we learn about him on this slide. Before we begin, I would like to quickly check whether our whole system is working, and we can also interact with each other. So you might see a poll on your screen, and the multiple answers are possible. So the first poll is, what usually determines the urgency of an emission control project? When I discussed with Bart lately, he told me a few things, but let's see, you as an audience, what is the urgency of emission control project when it comes to your industry or experience? You can answer and submit. Is it a scheduled environmental audit, new regulation, rising energy prices, a call from the regulator? If none of them, is it a call from the neighbor about the smell? Let's wait for another 5 seconds and see where we are. All right, there are mixed answers. And in order to discuss this quiz, I would like to get on the screen our first expert, Bart. But are you ready?
Yes, thank you.
Thank you. Over to you, Bart.
All right. Yes, that was a quiz that was quite funny. To be honest, the answer from my side is that we get calls for all of these things, and quite often they also all happen at once. So that's what we see in real life. I'm Bart. I'm here as a process guy and as an off-gas treatment expert, and I also am here as a sales and process integration group for, in this case, Oxytec. First of all, I'm quite honored to have quite a few of you here from all over the world for this event, so thank you for that. This slide, you see a thing that you might know, the top 10 of process industries that emit. And before we start, I would like to ask a question for all of you, and you can answer in the chat if you want. What branch are you from? I would like to know that, and you can, of course, place your answer in the chat if you want to see what branch you are from. So we see tank storage, that's good. Tank terminal, once again, rubber and recycling. Okay, cool. So that's quite a wide range. Painting and coatings, also extremely interesting. So yeah, cool. Okay. So regardless of what industry you are in, we have one theme today, which is emission control. Now, my talk won't exactly be about tech, but I will start with a thing that I feel is critical. We don't start with a process such as, for example, an RTO, UV, ozone, scrubbers, and so on. We generally start with your process, because in our view, most projects in this field do not fail because of bad equipment, but they fail because of incomplete view and also a lack to properly, let's say, understand what is happening. So how does your off-gas actually happen? When does it happen? And how does it change over time? So I want to go into that a little bit further. Next slide, please. So VOC emission is, of course, a main driver for global warming. I think we all know that, and therefore we have set thresholds. And as you can see in the graph on the right, these thresholds have gone only one way, and that is down. And they have gone down, you know, rather steeply, as you can see. And of course, the question is, global warming, is it an option that we even stop that, or even perhaps even reverse it? We can have a talk about that in a bar, I think. We don't need to go into that right now. However, I would like to say that there are also real life things that we can see happen by the fact that we have these thresholds. For example, the air quality has greatly improved over the past time. So that shows that this can have a real proper effect. I noted here a changing world, because I think we're not there yet. The world is changing, and I think we all know that the world can be a crazy place, as we see right now happening in the world. But regardless of what is happening in the world, if we look at slightly closer to home, and if we look at, for example, air quality, there are a few things that we see. For example, where I live in Holland here, we are quite small and rather full. So what we see is that housing moves ever closer to where actual things are being produced. One does also raise their actual voices quite a lot more freely and quite soon these days. So if there's, for example, a smell problem, that can go rather quickly. So then we've got all of these rather nice EU ESG, we've got the EU IED 2.0, blah, blah, blah. There's a lot of things happening. And also, for example, we want to move away from the use of gas and oil. So there's a lot happening. There's a lot happening at once. But in the end, it boils down to what is at the end of this slide. It's not just about rules. Treatment of your off-gas now makes whether you can or cannot produce. So it has a real effect on your day-to-day operations. And that is a change that we see. Next slide, please. So choosing the right technology for your exhaust stream. If we look at the off-gas treatment, this is the actual top 3 processes that we see in use at many of our clients these days. First of all, for example, of course, burning the off-gas. And that can be in all its forms. So that also includes, for example, RTOs and so forth. Then we see adsorption. There's a small fault in this graphic I see now, but we mean adsorption, for example, in this instance, AC beds, or for example, wet gas scrubbers. Now, none of these is good or bad. Our role is to ensure that we choose the right process for the right exhaust air stream. And that is not always exactly easy, certainly when you look at the trends we see these days, which you also see in this slide. For example, due to the fact that the rules are ever more strict, we see a need for treatment of off-gas streams with actually very low loads, but they still require treatment. And this is where, for example, plasma UV has a great role, I think. Certainly instead of, for example, the whole RTO idea, for example. So what I expect is that within the next time, I don't know exactly how long, but you will see that this UV, plasma, and so on will also be in this first list that you see next to the first three. Now, what we also see is processes where loads can go up, down very quickly. That can also be a problem for your treatment. And we also see, of course, a trend towards, in this instance, electrification, because we want to move away from the use of gas. But in the end, what I see as the most critical point here is that we start to look more and more at the actual cost it needs to run your exhaust air treatment process. Because you can build a really cool plant, but if the cost is so high that it doesn't work out, well, then we don't achieve the goal whatsoever. An example of that is, for example, the use of AC bed adsorption. In the past, and I think quite a few of you here have used these or still use it as a first fix. Why? Because they are fast to place. It doesn't really require a big process work on your plant, and it can actually solve your problem rather quickly. And quite often, it is still a very good first step to start your actual treatment, or it might even be the right choice on the long run. But at clients that we work for, we see that, and then I go back to the cost issue. However, it is not a very high price. It's not a very high price to place it. We see that it can be a very high cost option in the long run. And that's due to the fact that you can have very high off-gas streams. They can have higher loads, or for example, the off-gas can be, for example, can also be wet, and that can be a real problem. And then there's also a trend that we see more and more at clients is that they not only look at the treatment at their plant, but they look at the whole chain of the thing. Now, if you use an AC bed to adsorb products and they are being replaced, of course, this product also has to be cleaned and needs to be regenerated. Now, what does that mean? That actually means that still the off-gas is still burned / oxidized. So in fact, it is actually quasi an off-site oxidation. It doesn't mean that that is bad. I don't want to actually burn this whole thing down, but that's a trend that we see. Now, that actually means that to make the right choice becomes ever harder. But hopefully that's why we are here, and we are here to help. Next slide, please. Now, process first, tech second. That is what I call our holistic approach. And that is actually the core of all of the work that we do for our clients. We don't start with a process that we try to actually sell. We first start with these 5 questions, because without answering these 5 questions properly, there is no good groundwork to actually base your entire project on. And the answer to these questions makes out whether, let's say, UV, plasma, scrubbers, an RTO, oxidation, or even a hybrid process would make the most sense. Now, today, I won't answer all of these questions for you, but I do invite you to reflect on these questions during Frank's presentation, and also feel free to ask questions in the question and answer at the end. So that brings me actually to Frank. But first of all, the idea from our side is rather straight. Don't default on just one process. Evaluate your exhaust gas stream properly and make sure you've laid the proper groundwork. Now, that brings me to Frank. He will now make a nice travel and a nice deep dive into the world of plasma, ozone, and the practical application of these things. That's it from my side, and we will have a chat again if you want during the question and answer. Thank you, and Amol, back to you.
Thank you, Bart. I hope our attendees have learned at least something new, even though all of them are experienced. And as you said, Frank will have a deep dive. But before I get Frank on the screen, there's just a preparation with one of the quiz, and that will be reflected on the screen in 2 seconds. So the poll or the quiz is, when selecting emission control technology, what is usually the primary driver for you? And you can also have multiple selections if it's more than one, whether it's an investment cost, emission limit compliance, energy consumption or OPEX, order complaints, or ease of implementation. I put the poll on for another 5 seconds, and then we will see. All right, there are 14 responses. We have 34 attendees. Maybe I can wait for another couple of you. I see that emission limit compliance is leading. All right, so more than half have already voted. And with this, we can bring Frank to the screen, and he will explain us what is his experience, what are the primary drivers. So Frank, you're already here. Welcome, and let's deep dive.
Thank you, Amal, for the introduction, and thank you to the audience for the heavy interest in this technology. And as you can see on my first slide, first of all of these reasons are right. But what I find since a few years when I talk to customers on fairs, on conferences, or on site in the production halls, they are caring about their operation costs and since a few years about CO2 emissions. And this is combined if you are using gas. So a lot of them want to get CO2 free and they want to electrify. But first of all, I want to give you a short overview about my company. Next slide, please. Oxytec is working in the field of UV and plasma technology for water and air treatment. And they have a huge portfolio. We are dealing here with 100 employees roundabout, and since 25 years, we are applying this in food hygiene, gastronomy, healthy living for private residential areas, or also ship hygiene. But today we want to focus on industry applications, especially food, which is odor-driven, automobile paint and coating processes, which where we have to reduce VOC emissions, and waste recycling, biogas applications, where you often have both things, odors and VOCs. And yeah, I think this is for this slide. Please, next slide. The technology of UV and plasma is called non-thermal plasma. And this is state-of-the-art since 10 years now. It was the VDI guideline, the T2441 was published 2016. And since then, we have this technology in the market, and it's standardized, so it's not not an invention anymore. It's getting applied in the market more and more. And it's on the way to get the best available technology. I have to explain the difference between plasma and UV. On the left side, you can see a cold plasma reactor, when the black lines are the electrodes and the violet ones are the off gas, which is directly ionized via electrical field and activated. This is the advantage here is you have a direct contact and a direct transfer of the energy into the media. But as you can imagine, this is sensitive to dust and aerosols and things which can coat this technology or this technique. But I can tell you later how we deal with that. And on the right side, you can start this plasma inside a quartz tube in a quartz lamp, UV lamp, under protected conditions. And the plasma is taking the way via the UV light to get into the off gas, into the room where the off gas is streaming. And therefore, we have an electromagnetic radiation, which is excitating the off gas. Here we have complex reactions, starting with a photolysis, which is the direct attack of UV radiation to the VOC molecules. We have the formation of ozone, which takes also part in this radical chain reaction. And if we have humidity in the air, we will generate OH radicals. And all these three processes are working together in a synergetic way. And this takes, this is under ambient temperature conditions, not at 800 degrees. So the energy consumption is quite less. And the final product will be water and CO2. And we cannot say in nearly no case we can say we are CO2 free, because every VOC will end in a CO2, but we can say it's CO2 neutral. So please, next slide. Coming from this technology, which I explained very roughly, we can go into deeper another time. But for now, I want to explain how we apply this in techniques. And here you can see the smallest reactor we are using for industrial application. It's a reactor with 48 lamps. It has up to 1 to 7 kilowatts, and we can deal with 1 to 15,000 cubic meter per hour, depending on the load, on the concentration, on the conditions, the frame conditions. And if we have a higher flow, we can put them like Lego pieces in parallel. I use my, here. Can you see my cursor? You can put them in parallel, get to higher flow rates, and if the concentrations are increasing, we could put them in serial. That's all. It's very easy, plug and play. Next slide, please. But the key of a successful process is often the combination of different components. And here you can see a standard street for 30,000 cubic meters, where we are combining plasma, which is the first, the red one. Then we have a scrubber for humidification, for separation of aerosols. This is the orange one. And then we have a UV step, the green one, a ozone reaction zone built as a pipe, because the ozone reaction is very slow compared to the photolysis and the homolysis of the OH radicals. And finally, we are using a catalyst, which is normal cases an activated carbon vessel. Yeah, I think next slide will be a quiz again. Yeah.
All right, let me put another quiz, which is the last quiz for the day, by the way. And it will be on the screen. Yes. So how high and stable is your emissions? Is it high VOC and stable, low moderate VOC and stable, low moderate VOC, highly variable, or odor driven? Let's see. There are 15 responses. I will wait for a few more. I think, Frank, you already have a winner. I'll leave it to you again.
Yes, that's also my experience. As I said, or as we can see here, I think low, moderate VOC and highly variability. And I also, starting with the first question to my customers, do you know your process well enough? And I'm asking him about details. And one is the concentration, but the concentration is the most made mistake, because very often the customer says, okay, my maximum concentration is 1,000 or 2,000 milligrams per cubic meter. And then he buys a RTO and he's wondering why he has to pay so much gas costs anyhow. And therefore, I will show you here two examples of variable VOC emissions. Here on the left side, we have a drying of painting of barrels. And as you can see here, you have a variation over the drying process itself. You have pauses over the day. You have sometimes of emission without, sometimes of production without emissions. So for us, it's very important to know about the average concentration. This is much more useful than the maximum. We also have to know the maximum, but the average concentration is very important. For example, if you have a 16/5, that means 2 shifts per day and not on weekend. So you have a lot of pauses where you have to think over what I do with the RTO meanwhile. This is a real case, and on the right side, we also have a real case coming from a roasting company for cacao. And as you can see here, I don't know if everybody can see the scale, but normally over 90% of the time you have below 100 milligrams of emission, but they are causing odors, that's clear. And sometimes we have these high emissions when there's a quenching process, for example, and then it's nearly 1,000 milligram, and this is quite high. And if we know that, we can think about a peak smoother for this. But for the rest, we would design a normal system for UV. That's what we did. This customer bought a RTO 5 years ago, and he still have complaints about odor, and the costs are really high for him. So he's now replacing and put a UV there. Next slide, please. Yeah, the reality is normally very complex. You need to have a lot of knowledge to evaluate processes, even if they are always so different in the industry, varying so much. But I want to make it simple and easy to understand, so that it's also for you give something like a feast law to have a look on your own process. It first starts with the concentration. What concentration, average concentration you have? And if you can answer 0 to 500, it's a no-brainer. Then we can go directly into a basic design and help you. If you have a region between 500 and 1500 milligram, we have to go deeper into details and look about the pauses, what kind of VOCs, are they easy to degrade, etc. And as a first feast rule, I would say over 1500, we should use traditional conventional technology like RTO. With that knowledge, we also have to care for the optimal conditions for an UV or plasma application. One of them is the temperature. The optimal temperature is 20 to 60 degrees. And if it's higher, for example, when you come from a roasting process or from a drying oven, then we have to cool the air. The optimal humidity cause for formation of OH radicals is 40 to 100% humidity. And if it's below 40, I would say we moisten it. We put some water into the air. The dust and aerosol, liquid aerosol particles are never good. We try to remove them in front of the UV or the plasma. But if it's not perfect possible, we have an CIP, a cleaning in place, which cleans the lamps at night or at the weekend, so that you can have a stable process. And this is very important, to care for a good, stable process by a very good CIP. Please remember that. If you have peaks, as I said before, peaks over seconds or some minutes, we are using peak smoothers, which are reducing the peak to an average concentration, and this load on the peak smoother will be regenerated after the peak is gone. And regarding flow rate, there is no limit. We can build in modular streets by 30,000 cubic meters per hour and put them parallel one after the other. So with this portfolio of combinations, we can apply the technology as a standalone system with UV ozone or high power plasma or combinations of that. We can use it in combination with scrubbers. Its potential upgrade or pre-treatment as a pre-treatment for biofilters to activate the microorganisms with the activated oxygen we are producing, or we use it as a pre-treatment for existing activated carbon filters, where we are changing the role of the activated carbon from adsorption to catalysis. Because the catalysis is a very important reaction to remove residual ozone and to put together residual VOC and ozone particles on the AC surface. And last but not least, we can also go for replacement of RTOs, thermal or catalytic oxidation systems, or if it's needful to make a post-treatment after an RTO has done the main of the work but doesn't reach the final limits, then it can be a post-treatment. Yeah, so next slide, please. Advantages. I have to say, first of all, the feasibility has to be given. So we need to know if under your conditions, UV or plasma can work. If it is like this, then we have some advantages listed here. As I said before, we can, if we have this CO2 500 milligrams, you can very often reduce the consumption of energy and the related CO2 emissions by 80 to over 90%. With combinations and the CIP, we have stable operation against aerosols and particles. The system can be switched on and off like a lamp in your room. We have no standstills at revision days, because we have normally more than one line. So one line can run, the other can be maintained. We are not dealing with what we do with too much energy to heat energy recovery. If you have 800 degrees, it's fine. You can warm up your oven air or some other airs, but very often you don't need so much energy. And therefore, we can do this with heat pumps or other modern heating processes. The space and weight requirements are very low. The system is quite light. You can put them on the roof, under the ceiling, in the cellar, somewhere in the corner. So this is very often a point which is very important. No NOx or CO for generation. Formaldehyde is destroyed. These are no processes over 400 degrees. The upgrade or downgrade can be easily done because we are using these modular, as these Lego pieces, as I told you before. Yeah, and last but not least, we are not using chemicals or we are not producing normally waste. I think that's a lot. Next slide, please. And I want to give you finally an overview about costs. If we I have now compared to RTOs. If a customer has an old RTO and he has to replace it by a new system, we often find, it's not always the time, but we often find that we have around about 50% in CapEx in investment costs. And even if the RTO is very new and he has not to care about the investment cost of a new RTO, the operation costs are so low that we have a return of investment between 1 or 3 years. And when we put additionally the energy funding options, then it's getting a no-brainer very often. Next slide. I will show you here some reference cases. Only an overview. Pet food production on the right side is a very easy case. It's only odours in low concentrations. So this is a system for 40,000 cubic meters. And the funny thing here was after this was shown that it is successful, the main president of the enterprises said, okay, I want to have this in my headquarter. And today they built, I think, over 300,000 cubic meters per hour for this pet food production there for odor elimination. A completely other application is battery recycling in the automobile industry, which is a hype topic at the moment. Here we have to combine all what we have. That means on the left picture is plasma. In the middle we have the UV technology. On the right of this we have the catalyst, and even in the back you can see a scrubber. So this is made for 20,000 cubic meters per hour. Application: the pharmaceutical industry. On the left down, coating of pills and drugs. Here we can have emissions of IPA, ethanol and acetone from 1 to 7 grams per cubic meter. And we built a system, a high sophisticated system there, which can deal under for Swiss law emission limits. Then we have on the right side the paint printing color, which is a system for 18,000 cubic meters built also in Switzerland. It was running 10 years there, finally the production closed there, and the unit here, the air treatment system, was transformed to another site in another country, and it's working since then, since 2 years, still working fine. And in the middle, last one, it's the treatment of liquid waste. where they are heating up the water from the waste, and the emissions are going to this system. It's a system for 2,000 to 3,000 cubic meters, and it works. Yeah, this is an overview, and I think this brings us to the last slide where I don't know, it's the pre. I have to announce that if you are interested now, if you want to know more about this technology, you're invited to the workshop in Speyer, Germany in June, where we are highlighting the potentials and the limits to NTP, non-thermal plasma technologies. And you will, Bart will also be there, and you can learn a lot about the new and the conventional technologies. You can learn about energy savings and funding options. We will get reports from real cases, and the VDI guys are there. They can tell you about what the VDI means to us in Europe, and about last but not least, which is a hype. We are also training in artificial intelligence, AI, which is helping us to apply all our knowledge and expertise for these industrial applications. So I think that's it. Thank you for your attention, and I'm open for questions.
All right. Thank you, Frank, for deep dive. I'm sure our audience has learned a lot. And in the meantime, I saw a lot of questions for you, so be ready. Can I also get Frank on the screen so we can have a variety of questions? And Frank, just one thing, the announcement that you made, that training is 100% in German, and you wanted to have one in English in the near future.
That's right. Some of the guys will talk in English, like Bart. So the audience may understand German and English, but yeah, the most of them will be German, right? In the future, we will arrange an English one.
All right. And then if audience have more questions, they will definitely come back to you. So it's 16, 17. I think we have 10 to 11 minutes for questions. So I'm going to pick up some of them. Some of them we can reply on the email. And I also have some questions just to ensure that audience knows more than what they wrote here. So if possible, let's have answers between 30 to 40, 50 seconds so that we can cover at least 10 questions. But before I go to technical question, I know you are in thermal solutions or similar technologies since long, and there is a new partnership with Oxytec where you saw some gaps and you thought, okay, let's do something more. Let's add an additional solution. Can you tell us more about your partnership with Oxytec?
Well, yes, Amol, thank you. Well, the main goal that I actually hooked up with these guys when they actually asked us, I think half a year ago. First of all, just like with Kranz, it's also for them, it is the way they work that actually fits very well with us. So that's the first answer to the question. We also, so for us, the main goal is we want to solve for the client and not to just sell something. That's not the goal. I think that was also clear from what I said. And it actually fits perfectly, not only to replace RTOs, because I think the way that we design the whole RTO thing can work very well and can drastically reduce gas cost. But it all comes down to answering the 5 questions that I said, because if you have an RTO that uses a lot of gas, you didn't pretty much look at the first questions properly or have a very clear view of your exhaust air stream. But still, this fits exactly in the gap where generally an RTO would not make sense by itself. You need some form of pre-treatment or stuff like that to ensure that the RTO can run properly. And this fits perfectly within the trend that we see these days of to actually not use gas and so on. So that's why we actually want to work with them and have the option to offer this onto the market. Yeah.
Yeah, so if somebody wants to have a further conversation with you, get the answer of those 5 questions, and then you will exactly let them know what kind of technology you're selecting and why. After some
Yep,
conversation,
of course.
of course, not immediately after
Of course.
first email.
Yeah.
All right, I'll take some
Yeah.
technical question. Frank, when you were presenting, there was a question. The technology will be CO2 neutral and not CO2 free. Can you please elaborate on this? What's the difference between CO2 free and CO2 neutral? Interesting question.
Yeah, CO2 free would mean that the VOCs would remain, for example, because the final product of oxidation is always CO2 if you have an organic compound, a volatile organic compound. So you never can talk about CO2 free, only if you condense it with a cryo system. But in every case, you have to consider what energy you're using. And this is the main point. If you're using gas, if you have 100 milligrams of VOC and you're adding 2000 milligrams propane to burn it, then you increase the CO2 emission a lot. And it depends, okay, how is the electricity produced? If it's produced by a coal oven, it's still not CO2 free. But if you can make it regenerative, which is more and more coming, then you're coming more and more to the point that you are CO2 free or neutral.
Neutral, yeah. Yeah, and I think I would like to add to that. You know, there seems to be a thing where one says, well, to actually oxidize an off gas, I don't want that. But actually, what we do is we still oxidize it, only we do it not via heat, we do it through these routes. But if you look at the fact that the thresholds are so low, or they are even lower and lower and lower, the most optimal way to treat these products is still to have them properly oxidized. So, and because the global heating action of these products is much higher than what you are left with when you do a proper process treatment. So, yeah.
All right, thank you. Let me go to the next question. There's a question. Can you not make the technique flexible based on, let's say, input VOC loads or ingoing VOC load? That was the question. More lamps when needed. Otherwise, you have to have engineer on higher VOC loads and spend a lot of excess energy on lower loads.
Yeah. What is the question itself? Sorry.
So the question is, I can repeat the exact verbatim. Can you not make the technique flexible for ingoing VOC loads, more lamps as and when needed?
Yeah, surely. The technology is very flexible because you can switch on and switch off lamps according to the input. But you have to know when comes which input. You can measure this on the one hand by PIDs or FIDs, but FIDs are very expensive. PIDs could work, or you have a recipe, or you know when you have which production, so you can combine with the PLC how much UV you invest. Yeah, I think this answered this question.
Yeah.
Yeah, I think that's enough for now. As we can see the name of attendees, my promise if both the speakers accept, we would answer a little bit elongated version on their email address. So we don't need to take all the questions today as well. So there's a question for Frank again. How does this technology compare to cold plasma injection systems?
Yeah. I know. Yeah, and I'm in the committee for these plasma technologies, and I'm sitting there with the colleagues which are using injection systems. Injection systems, you have to know, they are always ionizing a partial stream and then injecting this ionized stream into the rest. So in the beginning, they have dilution of they make the flow rate bigger by 10 to 20%. You must know that. It affects your whole process. And this is the weakest. It's ozone which is working there, and you don't have any UV light. You don't have any direct contact of the plasma with the VOCs. It's more indirect. So the power is limited. What you can bring into your system. I think it can be used for odor treatment so far, for very low concentrations of VOC maybe, but not for middle concentrations. And middle means for me over 100 milligram per cubic meter. So this is my experience.
All right, there's a question for you again. Can NDP be used for halogenated emissions? And maybe it's good to explain what is halogenated emission. Not everybody knows. How corrosion resistant is the equipment for this kind of equipment? And is there an issue given there needs to be a certain humidity? So there are a couple of questions together. Number one, can it be used for halogenated emission?
Sorry, I didn't get you.
Can NDP be used for halogenated emissions?
Yes,
chlorine or
means
whatever.
chlorinated or fluorinated hydrocarbons. Yes and no. I have to explain why. Sorry. Chlorinated hydrocarbons, if you oxidize them, they are formating, they're generating HCl. You have to care for the HCl. So you must be corrosion stable. The same thing we have with fluorinated hydrocarbons, and you will get FCl. HF, yeah, thank you. And this is very dangerous. So it also depends on the concentration. And if it's very high concentrations, they would attack the lamp, UV lamp, because it's quartz, and quartz will suffer under HF. So it depends on the concentration there, and we have to be careful. If you have an oxidation process.
And are they corrosion resistant? So let's have a combination. Are they corrosion resistant?
The lamps?
Yeah, so equipment. So the question is, how corrosion resistant is that equipment? So maybe lamp or everything that is connected to it.
If I would say we have to care for the humidity there, because this is also driving the corrosion. And if it's low concentration of HF, we can deal with it, but at a certain range, we have to say, no, it's better to use another technology. Maybe plasma then. But okay. we have to be careful with HF or fluorinated hydrocarbons.
And is there any need of certain humidity while applying it?
Humidity is always good for the UV process. It helps. We can deal with 100%. Okay, we don't want to have the aerosols flying around and absorbing UV energy. So we have a droplet separator in front, but 100% humidity is fine. And also down to 40%, we can deal with that.
All right. Maybe we'll take one last question, maximum 30 seconds, and then I have a last question to conclude. Is there a list with the components available which can be treated by the UV or plasma technology?
We don't publish lists. Sorry, this is expert. This is IP knowledge, and we are training our AI with that. You can ask us. You can tell us your story or your application, and we make an evaluation. That's always, you cannot write books, because it's so complex in the wastewater and waste gas treatment of in the industry that you have so many different combinations. But we have a lot of knowledge where we can help you to say yes or no.
Yeah, exactly. I think that is critical. And also, I would like to say I see quite a few good questions, so thank you for that. I will promise that we will get back to you with an answer to these questions. So because I see who wrote the questions, so we can actually answer the questions via mail if you want after this. So I will do my best that we answer all of your questions, also even after this event. I will make sure that we do that.
Yes, email is great. I'll ensure that those are coming to your inbox. The last question to you, Bart. You have discussed and sold several RTOs. Is there any customer who comes to you and mention, "Oh, RTO is not working. I need non-thermal solution"?
RTOs that we build, no, of course not, because they work.
But that's
No, but
that's what
no,
every
but
competitor would say, correct?
that is the good answer, of course. No, but also generally because the field in which we have done it, we use the RTO as a more smart replacement for, let's say, the more old school processes where we burn the off gas with masses of gas. So there we did that first step. So no, not yet. But of course, I would be happy to do so because I think there is a great option here, and I would love to work with that a little bit more. So not yet, but we will see.
All right, thank you both of you. It's already 4:30. I just need another 30 seconds just to explain to our audience. Beam Process is partnered with Kranz, Gordium, Oxytec, Greatec, and Conta for the different technology. And if there is an interest for any of the product or services, please get in touch with us at hello@bmprocess.nl. Follow us on LinkedIn, follow Bart, and you also have email address from Frank, and we would ensure that if there's any discussion needed for particular technology or the topic, that would be answered. So with this, we would like to conclude today's webinar. Thanks. I think it was a quick and interesting conversation. The whole video will be recorded and we would put it on our website for repetitive observation and the discussion on the same topic. So thank you again. Thanks, Bart and Frank, for your discussions. And we hope to see our audience again in the upcoming webinar somewhere in the near future. And I hope some of them will also see you in the workshop that is planned in the month of June. Have a nice day and let's keep in touch.
Okay. Bye-bye.
Bye-bye.